wonderful good evening and welcome to a new episode of Video Wissen. My name is Jenny Wagner. I'm a research scientist at the Bahamas Advanced Study Institute and Conferences, and this is my very first talk here on this channel. There's no better way to start off than choosing a hot but controversial topic. And that's why today we will be talking about unidentified flying objects. Claims have been brought forward that the so-called UFOs violate the laws of physics as we know them, and that they should be based on technologies which exceed our current state-of-the-art by far. Whether this actually has to be the case, or whether we can try to explain these UFOs in terms of current known laws of physics and known technology, will be part of this talk and will be investigated. Enjoy watching! Before we dive deeper into the data analysis, I would like to map out the landscape of all the terms and definitions that are often used in this context. So let me start with the most general class of mysterious phenomena that we categorize as so-called unidentified aerial phenomena, UAP for short. We can define these UAPs as observed effects which seem to contradict the laws of physics as we know them, and which seem to disagree with our expectations based on the context and on our prior experience. To put this into more practical terms, have a look at the two example pictures on the left-hand side. On the top, we see a road ahead of us in a very dry region, and the road, which is very close to us, is also dry. So based on our prior experience, we wouldn't expect a whole pond of water which seems to be there at the road farther ahead of us. So this goes against the laws of physics as we know them, at least we think so. And at the bottom of the left-hand side, we see a picture which contains a modern version of the Flying Dutchman, meaning we see a ship which is not there. Actually, this ship is way beyond the horizon already, and what we see here is an image of the ship projected onto the horizon for us. So this very spooky experience also seems to contradict the laws of physics as we know them. But both of these phenomena can be explained in terms of thermodynamics and can be understood based on laws of physics as we know them. These phenomena just do not occur very often, and so they seem to go against our prior experience because this effect is quite rare. And it is based on the fact that we can have an inversion layer of cold air being closer to the ground and hot air being stacked on top of that. And with this unusual stacking of cold and hot air, this causes a so-called inversion layer, such that the light rays coming towards us are bent and cause these spooky phenomena to appear. So much about the general class of potential unidentified phenomena. Let's now come to a much more interesting subclass, namely the class of unidentified flying objects, UFOs for short. Sometimes they are also called anomalous aerial vehicles, AAVs. But I would like to stick to the term UFOs because it's much more common. This subgroup of UAPs can be characterized as being observed vessels, meaning real objects, which perform flight maneuvers exceeding those possible with state-of-the-art current technologies. And you can see one of these examples here on the slide. So we see two screenshots from a video released by the New York Times in 2017. It's called the gimbal video. And on the left-hand side, you see a highly symmetric, unidentified flying object as a black shadow. And on the right-hand side, you see the same object a little bit later as a white shadow. It's just the inverted image here. And in both of these pictures here, you see that it's a highly symmetric object. And as far as we know it, we have not identified which object it actually is. And it seems in the video that it can perform flight maneuvers defying the laws of physics as we know them. But according to the videos that Mike West and his colleagues have put forward, it is possible to explain these phenomena that we see on the video in terms of known physics. And here the resolution is that we have a real unidentified flying object, for instance, a civil airplane or a combat jet. We just don't know what it actually was. And the effects that we see as impossible flight maneuvers are not performed by this object itself, but they are caused by the mounting of the camera and the hardware and the data acquisition itself. So these flight maneuvers are actually not real, but caused as image processing artifacts. So this special case here seems to be a combination of an unidentified earthly flying object and image processing artifacts. It can thus be explained in terms of known physics and in terms of known technologies. This is the case for over 98% of all the UFO reports that we have so far. But imagine there is a sign of extraterrestrial technosignatures on this Earth. How would we search this needle in the haystack among all these reports, which more or less boil down to very earthly phenomena? In order to do so, the colleagues who have worked on UFOs for quite some time decided to set up criteria in order to look for signs of extraterrestrial technosignatures. So what features do we need for UAPs to be very likely of extraterrestrial origin and not just some phenomenon which we just can't explain based on the sparsity of the data? So let's start with the first of the 5 criteria to be a very good candidate for an extraterrestrial UAP. It is instantaneous acceleration, because we have UFO examples that hint at accelerations of 70 to over 5,000 times the gravitational acceleration of Earth. This is assuming a constant acceleration model, because often we lack specific data to have more information whether the acceleration was actually changing or not. To see whether or not this is a huge amount of acceleration, let's compare to known examples on Earth. The fastest known accelerating organism that we know today, which is in the Guinness Book of World Records, is a fungus called Philobulus crystallinus. And this fungus is able to throw away the black head that you see here on the picture and accelerate this black little head from 0 to 20 kilometers per hour within just 2 microseconds. So doing the math, this amounts to over 20,000 times g, so 20,000 times the gravitational acceleration of Earth. So compared to that, the UFO examples seem to be rather slowly accelerating. Now let's compare to the fastest accelerating car that we have to date, which goes by the name that you see here on the slide. Surprisingly, it's actually an electric car, which has been created and built by German engineers. And it is able to go from 0 to 100 kilometers per hour in just 1.461 seconds. Doing the math here, this just amounts to a bit less than 2g acceleration, but we should take into account that this car is driven by a human being. And our human tolerance for high accelerations is actually quite low. Studies have shown that we can tolerate 45g for only 0.044 seconds without causing any damage to our organism. Reducing the acceleration to 25g, we can endure this for 0.2 seconds. But our tolerance to high accelerations is vastly decreasing for increasing exposure time. So turning this argument around, if we take a look at the accelerations that the UFOs show, this means that if these accelerations are for real, then these vessels are definitely not navigated by any human being or not by any carbon-based life as we know it. So most likely this leaves us with UFOs either being remotely controlled drones or being driven by sentient beings from another world which are not constructed and created in the way as we are. because we cannot tolerate these accelerations for that large amount of time as we see these UFOs accelerating. Now let's come to the second criterion to be a very likely candidate for extraterrestrial UFO. It's hypersonic velocities. To just remind you briefly, hypersonic velocities are those speeds which exceed 5 times the speed of sound in the medium in which we are traveling. More or less, this amounts to speeds of over 6,000 kilometers per hour in air. The UFOs that we have recorded so far can actually have 55 to 60 times the speed of sound as we have observed them. Comparing these velocities to the fastest plane that we have on Earth, this is a Lockheed SR-71 Blackbird. This plane is rather slow because it can only go at 3.3 times the sound speed. But we still have to take into account that this plane is navigated by a human pilot. If we would like to go to higher velocities, then we end up with, for instance, gliding missiles like the Dongfeng 17 that you see at the bottom of the slide here. This has been constructed by the Chinese military and it can achieve hypersonic velocities, meaning Mach 5. But there have been missiles created around the Earth by several countries which can even go higher. So unless we are talking about rocket science like spaceships, or we are talking about gliding missiles as these ones here, we do not have any means of transport for human beings which could exceed the Mach 3.3. So observing a UFO going at hypersonic velocities seems to be a good hint for it to be of extraterrestrial origin. Nevertheless, they could also go at lower speeds and just show weird flight maneuvers to make them look suspicious for us, because these flight maneuvers violate the laws of physics as we know them. Now we come to the third criterion to be a very good UFO candidate of extraterrestrial origin, namely the low observability. Sometimes this also goes by the name of cloaking. So one of the characteristics is that we haven't observed any sonic boom when these objects are accelerating through the sound speed barrier. So this is a very peculiar characteristic of an extraterrestrial UAP, because so far we have not achieved to suppress this sonic boom, which has already been one of the major obstacles to create and build supersonic airplanes that can transport human beings. The second point for low observability is that when we take a look at these infrared pictures that are shown on the slide, we usually have a hard time to estimate the true shapes of these objects, because they usually move very fast and there is a certain glow around these objects such that the true shape seems to be cloaked or hidden from us. The fourth criterion to be a very good candidate is that we can observe transmedium operability, meaning that these UFOs can function in different environments. For instance, we have radar data seeing objects coming from outer space, entering the Earth's atmosphere, and then submerging into water. But the last and most peculiar hint to be of extraterrestrial origin is the anti-gravity feature. This means that we lack any signs of the propulsion mechanism of these vessels. So there are no wings, there are no propellers, and when they hover over water, we do not see any outflow of any combustion mechanism. In addition, they usually have a highly symmetric shape, and there doesn't seem to be a preferred direction in which they would like to go. What will play a role later, they are often seen to travel in groups, which I will use later to describe or to put forward my idea how this anti-gravity feature can be realized with known technologies. So altogether, we now have 5 features, 5 characteristics that we can observe and that seem to be unlikely to be explainable in terms of our current technology and in terms of what we can build as human beings. Nevertheless, let's now turn the question around and ask, how would we as human beings construct such UFOs in order to come as closely as possible to all of these 5 criteria. So how would we construct a UFO? Let's have a look at the current state of the art and what we could do if we were to build such vessels and if we were to navigate such flight maneuvers as we observe them, given that there are no image processing artifacts and there are actual, real, physical flight maneuvers. So let's start with the optimum vessel design for flying in different media, and I would like to focus on air as the surrounding medium. There we definitely have to minimize the drag forces for a broad range of velocities, and we have to suppress the sonic boom. This has been the question for missile design since the 1950s. And on the left-hand side of the slide here, you can see an excerpt, a table, from an engineering book from the 1960s, where different nose designs have been investigated for minimizing drag forces, for velocities which range from a bit below the speed of sound, so Mach numbers of 0.8, to supersonic velocities for Mach numbers of about 2.0. And as you can see here, a simple cone as a shape to minimize drag forces is actually an inferior profile because it is hard to navigate through all these different velocities. But we find here that we have 2 profiles which actually are superior or even good in order to minimize the drag forces for this velocity range that we are considering here. This is the von Karman profile and what is called the power law profile, which just has the function shape of a square root. And these 2 profiles are also good candidates that could be suitable for hypersonic velocities because they are already very good in order to drive us from transsonic velocities to supersonic velocities. You can see the 2 different profile shapes on the right-hand side in the plot. The von Karman profile is the one with the black lines, and the square root profile, the power law profile, is the one with the red lines. In order to make it very general, I scaled the length to 1, and I did the same with the radius. But as we will see later, we can scale this to actually create a UFO shape out of this by just normalizing to a different length and to a different radius. It's pretty easy. But minimizing drag forces is not the only thing we have to care for. We also have to optimize the heat transfer if we would really like to go to hypersonic velocities. In addition, in order to put forward my approach, how we could navigate these vessels, we also have to apply charges on the surface of these vessels. So I would like to have conducting material. And in addition, last but not least, we should optimize the mass. The lift-off weight is a very decisive characteristic in order to design such vessels. Taking all of this together, and having a brief look in the internet, I think silicon carbide could be a very good material because, first of all, it matches the descriptions that we have for such UFOs. You can see this silvery shiny structure at the bottom of the page here on the left-hand side. There you can see several silicon carbide crystals. So the appearance seems to fit quite well. And if you take a look at the right-hand side, you see a picture of a processed silicon carbide compound. This picture has been taken from the NASA Technology Transfer Program, and it shows that this material is actually used as heat shields for the space shuttle. So all in all, we already have a very promising material, and we have an idea how we can design the profile shape in order to minimize the drag forces. Now let's put this knowledge to use and let's estimate for 3 different case studies how heavy such UFOs can be and in how far they could be compared to actually airborne objects that we have constructed as human beings. In order to do so, I would like to discuss 3 vessels that have actually been observed and which are discussed in the paper by Kevin Knuth and colleagues in the journal Entropy from 2019. He describes different encounters of human beings and UFOs. And in this paper you can see that we have 3 different types of vessels which have been sighted. The first one is a large disk, which is estimated to have a diameter of 210 to 330 meters. Unfortunately, the witness did not give any hint what the height of this object is. Therefore, let's assume, just to get a ballpark number, that it's a very thin disk, such that we could estimate the height to be 90 to 30 meters. The next disk, which was observed, is of medium size, about 60 to 90 meters in diameter. And here again the height was missing. So let's assume that we have the same aspect ratio like the large disk. Then the height of this medium disk is about 5.5 to 8 meters. Last but not least, we have the famous Tic Tacs, which are a small capsule in shape, and they have been characterized a bit more tightly. There we assume that they have a length of 17 meters and that they have a height or diameter in the other directions of about 3 to 4.5 meters. Now, to get a first rather optimistic estimate on the mass of such vessels, I assume that they are thin shells of silicon carbide of a thickness of about 5 centimeters, because these 5 centimeters are exactly the thickness of the heat shields at the space shuttle. So now let's assume that we take these vessels to be like hollow shells with a certain profile and built from a certain material. Then we can look at the 2 profile shapes that we have to minimize the drag forces, the von Karman profile and the power law profile. And we can try to use these profiles to get disks and capsules. So for the disks, I now use the von Karman profile and I rotate this profile around the y-axis in order to get a disky shape. And then I mirror the upper part to the lower part in order to get a full UFO. I do a similar thing to get a small capsule. I take the power law profile, I rotate it around the x-axis to get one part of the capsule from the left-hand side, and then I mirror this thing to the right-hand side in order to get the right part of the Tic Tac. So now we have the volume of these UFO shells, and having the volume, we can multiply this by the density of silicon carbide to get a mass estimate of these 3 different vessels. You can see the estimates in the plot on the right-hand side, and there, for the sake of completeness, I plotted what if the Tic Tacs actually had a von Karman profile, what if the Tic Tacs had this square root profile that I just described. And I did exactly the same for the disks in order to get an encompassing picture and ranges of possible masses. But these masses range from 10 tons to 10,000 tons. Is this a lot or not? Let's compare to the lift-off weights, the maximum lift-off weights that we have for our vessels. For instance, there is the FA-18 Super Hornet, which is a combat jet, which has a maximum takeoff weight of 30 tons. The largest plane to ever take off is the Antonov Miria, which had a lift-off weight of 640 tons. So compared to that, our smallest little Tic Tac vessel, having a von Karman profile with only 6,000 kilograms, is actually well in the realm of possibilities. Taking a closer look, only the largest vessels that we have here exceed the lift-off mass of the Antonov. So for these vessels, it may be hard to actually leave ground, but for all the others, it seems to be possible. So we have found a certain material to build these vessels. We have found profile shapes that minimize the drag forces. Now the big question that remains is, how do we navigate these vessels? And here I would like to put forward an idea which has not been discussed up to my knowledge in the literature so far. So let's assume that we have a conducting surface for these vessels and that we bring on charges on these surfaces, and then we can use the electromagnetic fields of Earth in order to navigate these UFOs. This is the claim, but the question is, can this be made feasible given the technology that we have and within the laws of physics as we know them? So now let's have a look what the environmental physicists tell us about the electromagnetic fields of Earth that we can use for navigation. We have a global electric field, which is called the fair weather cycle, where we have a positively charged ionosphere and we have a negatively charged ground level. So the electric field lines go from top, ionosphere, to bottom, sea level. In altitudes below 1.5 kilometers, we more or less have a constant electric field strength of about 100 volts per meter. Sometimes it's more, sometimes it's less. It depends on the conditions on the ground. Above that, we have a discontinuity layer, and then we have an exponentially decreasing electrical field for increasing height. As reference to the exponential law, I give here a reference field strength of 45 volts per meter for reference height of 4.5 kilometers. So we can insert these two values into the exponential law and then get the electric field strength for altitudes above 1.5 kilometers. In addition to that, we also have local electric fields, for instance in clouds. As measurements show, these local electric fields, which also cause perturbing weather conditions like thunderstorms, these electric field strength can be up to 100 kilovolts per meter, up to our current knowledge. Compared to this electric field, the global magnetic field seems to be rather weak, because there we have field strength of around 50 microtesla, which is very small. And for the southern hemisphere, we have an electromagnetic field pointing upwards. For the northern hemisphere, we have an electric field pointing downwards. So now we have outlined all the electromagnetic fields of Earth that can be used to navigate charged UFOs. Let's now have a look at the first example, a very simple example, the case of the flight maneuver which is called hovering, meaning this UFO stands still in the air. So as you can see in the left picture, standing still means a balance of two forces. And these two forces are on the one hand side the electric force, which now points upwards towards the positively charged ionosphere, because I have assumed that I have put a negative charge on the surface of my UFO. The charge is denoted by capital Q. And this force is supposed to balance now the gravitational force which pulls the UFO downwards. And this is because the UFO has a certain mass, capital M, and it is pulled downward by the gravitational acceleration of Earth, which is denoted by small g, and which has a value of 9.81 meters per second squared. So let's balance these two forces as shown on the right-hand side of the slide, where we have the electrical force, which is Q times the electrical field strength E, is equal to the mass times the gravitational acceleration of Earth. Then we can solve this equation for the charge to mass ratio of this UFO. And we find that this is now completely determined by the external conditions. Namely, it's the ratio between G and E. So having our three different vessel types, we can now calculate the Q over M ratio for these three different types of UFOs and see what charge would I have to put on a UFO in order to make it hover. So let's start with a very simple case. We assume that we have a tic-tac UFO which is hovering very close to sea level. So let's assume we take the electric field strength at 0 meters above ground. Then we insert about 100 volts per meter into the equation shown in the red box. This gives us a Q over M ratio of 0.1 Coulomb per kilogram. This implies for the tic-tac shaped UFO a charge of about 1.3 kilocoulomb. Is this a lot or not? Take for comparison that a lightning bolt in a thunderstorm can have about 10 coulomb. So actually this charge is quite a lot. And if we now go to higher altitudes, for instance 10 kilometers, which is the altitude where planes usually fly, then we have a reduced electric field of 5 volts per meter, meaning the Q over M ratio increases and the charge that we need to put on our UFO to make it hover even increases more. So this seems to be very challenging. Now let's take a look if we change the shape of the UFO, and let's take the medium disk. And let's assume that it hovers at a medium altitude of about 3 kilometers. Then we have an electric field strength of 23 volts per meter, which gives us a Q over M ratio comparable to the one of our first case here, 0.4 coulomb per kilogram. But still we end up with a very high charge that we have to put on this medium-sized disk UFO. So this doesn't seem to be feasible. But now let's take into account the local electrical fields, which can be up to 100 kilovolts per meter. Then our Q over M ratio decreases by orders of magnitude. And we end up, even for the medium-sized disk, with a charge that we have to put onto this UFO of 47 coulombs to make it hover. And this now is again possible, or it seems at least more likely than just taking the global electric field, because there the charges definitely seem to be very, very high, and it gets more and more difficult to find material which can actually take that much charges on it. So far so good. We can explain the hovering in terms of this charged UFO and the motion in a global plus a local electric field. Now let's come to a more complicated maneuver. Let's assume that we also add a horizontal motion to this vertical hovering. There has been a case reported by Japan Airlines pilots in 1986, the famous Japan Airlines flight 1628, in which we saw a UFO that was circling around the plane at a certain distance. Let's try to explain this motion that the Japan Airlines pilots reported in terms of a motion in a constant magnetic field. So we have a UFO which starts hovering at an altitude of 100 kilometers per hour and which stays in front of an airplane at a certain height, and this height is not changing. Then we balance again the vertical electrical force with gravity in order to get our Q over M ratio, which is again given by G over the vertical electric field. And now, without changing the altitude, meaning this Q over M ratio stays the same, this UFO now moves horizontally towards the back of the plane. And as the pilots reported, it was about 12 kilometers in front of them, and after 12 seconds, it was about 12 kilometers behind them. This means that the circle can be assumed to have a radius of 12 kilometers. And now, a charged particle moving in a constant magnetic field can be described to move around a circle according to the Lorentz force. And this Lorentz force is then balanced by the centrifugal force that takes the UFO farther apart from the plane. So let's do the calculation that the Lorentz force, which is the charge times the velocity times the magnetic field strength, equals the centrifugal force, which is the mass times the angular velocity squared times the radius. Then all quantities that we see in this equation here, particularly the velocity for the Lorentz force, which we can express as the radius times the angular velocity, and then we can express the angular velocity in terms of the time it takes to complete one orbit in this constant magnetic field. And the total time to complete such a motion is 24 seconds, because it took 12 seconds to go half of this way. So all in all, the only quantity that we do not know in this equation is the magnetic field strength. So let's solve for the magnetic field strength, and we find that this is now dependent on the orbiting time, capital T, and on the charge over mass ratio that we have already calculated from the balancing of the vertical electrical force with gravity. So we now have a prediction for the magnetic field strength. How large does it have to be in order to fulfill the requirements that have been reported by the pilots? Let's have a look. So we were traveling at an altitude of 10 kilometers. The electric field there is 5 volts per meter if we just take into account the global electric field. And these pilots said that they encountered a large disk UFO, meaning we have a Q/M ratio of 2 coulombs per kilogram. This amounts to a magnetic field strength of 0.1 Tesla. This is more or less the field strength that sunspots have. This is not that much because we have much larger magnetic fields, but it still exceeds the 5 microtesla of the global magnetic fields by many orders of magnitude. Let's now think what happens if we take into account the local electrical fields to change the Q/M ratio. This is actually counterproductive because the Q/M ratio, when it goes down, increases the magnetic field strength. So we end up with a higher magnetic field strength that is needed in order to explain this motion. So all in all, using magnetic fields seems to be rather unlikely because the magnetic field strength that we know on Earth are way too small in order to explain this scenario. So at least this scenario is most likely not caused by any magnetic field. So let's go back again to our electrical fields. Now, again, let's take the hovering at the starting point. So the vertical electrical force balances the gravity to get the Q/M ratio. And now, instead of assuming that the UFO is driven towards the other end by the Lorentz force, we now just model the motion as a simple horizontal acceleration caused by an electric force. The sources that cause the UFO to be attracted to the other side can now come either from positively charged clouds from the local electric field, or, as I said, UFOs like to travel in groups, so this means that we could also have other additional UFOs helping the natural field configuration to be enhanced for this motion to happen. And here I would like to make a ballpark estimate again and a very simplified model. So I assume that the electric horizontal acceleration towards this positive cloud or towards a positively charged UFO happens as a motion starting from rest and then being constantly accelerated over the whole distance and over the whole time. So we model this as we have to travel 24 kilometers, which is twice this radius, and this then equals 1/2 times the acceleration times the time that is required squared. So we can solve this one for the acceleration in terms of the known quantities, and then we can apply Newton's second law, saying that the mass times the acceleration now equals the electrical force, which is the charge of the UFO, times the horizontal electrical field that is required to make this motion happen. And again, in this equation, we do not know the horizontal electrical field, so we can solve for it in terms of all the other known quantities. So we end up with the equation in the second red box here, that the electrical field in horizontal direction is now given in terms of the distance which is traveled, the time it takes, and again our Q/M ratio of the UFO, which has been found by the hovering condition in the first maneuver already. Inserting the numbers that we assume now again we are traveling at an altitude of 10 kilometers and that we have a certain Q/M ratio for our largest disk, we now end up with a horizontal electrical field of 170 volts per meter. And this 170 volts per meter is just about twice the electrical field that we have from sea level to 1.5 kilometers altitude. So again, this seems to be possible, this seems to be feasible, and it seems to be more likely to cause this motion than the magnetic field as we saw on the previous slide. Let's now come to my favorite flight maneuver, the so-called swooping. In the Nimitz encounters seen in 2004, there were some radar data showing up of groups of potential UFOs coming from outer space, entering Earth's atmosphere, and then the radar showed that at an altitude of about 8.5 kilometers, they started to perform a swooping maneuver, ending up at 15 meters above sea level in only 0.78 seconds. This is a very high velocity, and now you could ask, imagine these were just like little asteroids falling from space. And let's assume that the distance they have to travel is 10 kilometers in height. And let's assume that they take 1 second to do this. If they have reached the final constant velocity that can be attained when traveling through air, then this would amount to a constant velocity of 100 kilometers per second. So this model of a constant velocity is highly unlikely, and it seems highly unlikely on top of that these were just stones falling from the sky and entering Earth's atmosphere. So it seems very likely that there is an accelerating force additionally pulling these objects down to the ground level. So let's investigate this in the framework of a charged UFO being attracted by the negative charge at the ground level. Here, of course, we need to assume that we can put a positive charge on the surface of the UFO in order to make it be attracted to the ground level. And for the sake of simplicity, to get just a first rough estimate, I now assume that we have a local electrical field driving this motion, and I assume that it's just an effective averaged electrical field over the entire height that is traveled. So the idea here is to model the total acceleration as an electric acceleration plus the gravitational acceleration, both pulling the UFO downwards. And then we know that the height which is traveled is the distance between these 8.5 kilometers and the 15 meters sea level. And this is, of course, again, an accelerated motion. And I assume, again, for simplicity, that it starts at rest and we have a constant acceleration over the entire time that is traveled, the 0.78 seconds. The radar data, unfortunately, doesn't give us any further hint about what actually happens with the acceleration because the resolution was not good enough to resolve the entire motion along the traveled path. So taking these two equations that we see here, we can now solve for the Q/M ratio that is required to make the UFO perform this motion. And we see that the Q/M ratio depends on the height that is traveled, on the gravitational acceleration of Earth, on the time that it takes, and of course on this electrical field strength that I still have to specify. Now you can ask, what about the drag forces here? Of course, the drag forces also play a role, but they are negligible compared to the other two. And if I include these drag forces into the calculation, the formula will get a little bit more clumsy. But what I see here is definitely a lower bound because any drag force that has to be cancelled in addition to what I have here will just increase the Q/M ratio. So this ratio that I get here is a lower bound that I need, and the Q/M can just increase if I take into account the drag forces as well. So again, let's insert some numbers. If I assume that the effective field is 100 volts per meter, then the Q/M ratio amounts to 280 coulomb per kilogram. This is again quite high, and it seems to be putting a lot of charge again on this UFO, which may be physically impossible based on the materials that we currently know. But again, if I take into account the local electric field, I increase the electric field strength by 3 orders of magnitude, meaning I decrease my Q/M ratio by 3 orders of magnitude. And as a consequence, I end up with a Q/M ratio, which again seems to be feasible based on what we know today as good semiconducting materials. So first and foremost, we know that it is possible to explain the shapes that these UFOs could have in terms of minimizing drag forces, optimizing for heat transfer, and minimizing the takeoff weight. In addition, I also found a very good material which allows us to put surface charges on these UFOs in order to make them navigate in Earth's magnetic and electrical field. As we found in addition, these magnetic fields on Earth seem to be very small and weak, actually too weak to explain these motions, if the propulsion mechanism is actually of electromagnetic origin. But on the other hand, what is left? I mean, if there are no wings, if there are no propellers, what propulsion mechanism could we use? There is only electromagnetism and gravity left. And gravity, again, is a very weak force compared to electromagnetic forces. So it seems to be a very plausible approach to start with this electromagnetic idea. And as I could show, the maneuvers that we saw can be explained in terms of this framework, in terms of this model. And the natural field that we have, the global electrical field, seems to be rather weak. But if we take into account the local electrical perturbations, then all these motions seem to be possible. If we additionally take into account that these UFOs travel in groups, we can enhance the natural configuration by putting certain charges on these UFOs. And we also see that these UFOs usually try to keep the distance to these airplanes. Take the 12 kilometers in the Japan Airlines example. This could also be a hint that they are driving using electromagnetic forces, and that they are staying away from planes in order not to disturb their electric equipment. So taking everything together, the construction of UFOs seems to be possible given today's technology and given today's material. And the flight maneuvers that we see, or those that I've shown you, seem to be possible, seem to be explainable within this framework. So what is left? What do we want to know? I mean, the most pressing questions that still remain open is who builds these objects and what are the purposes of these flights? Why are they performing these weird flight maneuvers? And I think a question which might be very important for our sustainability in the future: could we exploit this technology as a more sustainable and faster way of transport for us as human beings? I mean, we need not use the full range of all these high accelerations and hypersonic velocities. But in the end, being able to navigate with electromagnetic forces seems to be very environmental friendly. So why not have a look at this idea as a way of transport? For me personally, it's less important whether these guys built the UFOs or whether we built these UFOs. Because studying these phenomena can bring a lot of different branches of sciences together, and in this interdisciplinary endeavor, we will learn a lot and we will gain a lot of insights, for instance, into environmental physics. We will gain progress in engineering, and we will also learn a lot more about the laws of physics which are immediately happening on our planet. So that's all for me from today, and the two of us now go and phone home while we are waiting eagerly for your questions, suggestions and comments that you can leave under the video. Thanks a lot for watching, and see you next time.